Hello everybody, thank you for watching my YouTube video on Kubernetes. In this topic, we are going to deal with horizontal pod autoscaler. Autoscaling is an approach to automatically scale workload upon up or down based on your resource usage. It can adjust the capacity based on your need. Say one day you have a workload of more requests coming in, other day it's an idle. So during the point of time, autoscaling will be really useful. In, and at the same time, in autoscaling is also a good feature. In an example where case like you are launching an application product or a product launch, on the first day you will see more hits. On later stage, the request will be very less. So on the first few days, you definitely need the request to be served to users. In that case of scenarios, auto scaling will be really helpful because you will see the more number of hits will be coming to that, and application servers or web servers cannot be able to handle the load. So auto scaling will be in two-dimensional mode. So two dimensions, basically a cluster autoscaler or horizontal pod autoscaler. Cluster autoscaler that deals with the uh, node scaling operations. So horizontal pod autoscaler will automatically scale the number of pods in a deployment mode or a replica set. Autoscaling in Kubernetes will normally decide how to increase a pod based on the CPU or memory. The CPU or memory triggers, it will scale more pods or lessen it. Even you can even configure how much pod you want. That can be done using custom metric or a multiple metric or even external metric. The horizontal pod autoscaler automatically scales the number of pod in the replication controller or a deployment set, mainly with the CPU observation. In the demo, I can show you how it normally happens. So here, this is a diagram which normally talks about how the horizontal pod autoscaling will really work. So when the user creates the autoscaling functionality, he will set up an mode using a deployment or replication controller. So you want minimum 2, maximum 5, and the CPU percentage is 80. Horizontal pod autoscaler will have its resource metric, and based on the resource metric it will check, okay, so if the CPU reaches more than 80 percentage immediately, based on the limits set on to the autoscaling group, it will launch the pod. Once the CPU state is normal and comes back to the original state, it will bring down the pod. So let's have the demo. So I'm going to create an auto scaling group now. Let me create the first metric. So let me create the metrics first. So it's trying to download the and create the metrics server, mainly the pods. Okay, so we have created it. Now let's create the pods and the deployment model. I'm going to create the service and the deployment model. So let's go to the pod. So you can see here. So pod info service and the pod deployment service. And so in the pod deployment, we are setting two replicas. Okay, so on port 998, we are using it. And at the same time, we are specifying the pod info HPA. A custom level is there. Okay, so we can do it based on the HPA is basically you can create two replicas, minimum of two replicas, maximum of 10. So what I'm going to do now is that is I'm going to edit it. Okay, I'm going to keep it minimum replica of 2 and max replica of 15. Okay, so in case of CPU, it immediately can scale to 15. Okay, and let's see that we are able to do that. So first I'm creating the pod, then I'm creating the deployment model. So it's created. So kubectl get deployment. Sorry, typo. I noticed it. Okay, so current state we as we said for the pod is basically two desired state. So always you can see there will be two pod will be running. Okay, there will be always two pods will be running now. Now let's create the HPA. So I okay, so it's running on node 2, one and running on node 2, another on node 3. Now let's create the HPA now. That is not a point. I've just already customized it. And now and then we have to check the service now. kubectl get services. Okay, so we have the pod here. Now curl http // colon 9898 is exposed to 9898. Okay, so it's deployed in a Go language. So we are trying to access this URL. Okay, we have deployed a prod. Now we can able to get it. Now let's create the HPA first. So in the HPA, I've already said I've created an horizontal pod auto scaling group. Let's create it. kubectl get HPA. Okay, so describe HPA pod info. So what we are trying at the moment we are going to do is that is when the CPU spikes to 70%. Okay, so we have 200 millicore. Okay, 200 millicore, 200 MIB. So MIB is memory. So when the memory reaches or the CPU threshold reaches, okay, so greater than 70%, immediately the pod its current state is 2, it can be desired to 3. Okay, the minimum 2 and maximum can be 13 can be done. So what will happen is in the CPU memory reaches, automatically it can scale to 13. So let's see that whether it is possible or not. Okay, so kubectl get HPA. So I've already I've already kicked off, and let's see how much is the pod is at the moment now. kubectl get pods. So we have three. The desired state is actually we have it says minimum three. We starting when we deployed we said two, and now it is increased the additional number. So that's HPA is doing it out. So horizontal pod auto scaling is doing it out. So now let's check it out. So we'll load test it now. So I'm going to use a curl. So let's get it. So kubectl get services. Okay, so I'm going to do the load testing. So I'm going to increase the load. So you can see, you can see that is 100% increase greater than CPU. Now it started to create containers automatically. So if the load keep it's greater than 70%, so what is happening at the moment is you can see the pod is getting created. So from minimum to 2, it's now it has been trying to increasing the pod to 5 now. Maximum we can go up to 13. So let's see how much pod we have got at the moment. So 1, 2, 3, 4, 5. So from 3 it has increased to 5. So let's see now. So I have to stress more. So let's stress it more. So 175%. Now you can see the maximum pod count has been increased now. So you can see how much pods at the moment. Yeah, so containers are creating up. So 11 pods at the moment we are having, pods hyphen overwide. Yeah, so it's been creating across the various 3 node cluster. So now I'm just going to reduce the stress. Automatically you can see the CPU or the memory usage will come down. So it is 150% now. So let's see, and there is will be in the pods, how many pods we are having at the moment. So pod automatically will the HPA will decide and will terminate the. So we had earlier around 11 and it is scaled up to 15. It should be drastically reduced in 5 minutes. Let's pause it for a while. So guys, after a few minutes, I've noticed that the CPU and the memory percentage has been reduced. So we can see it is now around less than a 70 percentage. So we can see the pod has drastically come down. So get pods. Yeah. So this desired state is 3. It is coming out to 3. Yeah. So this is what auto scaling is about. Auto scaling will be really helpful in the production environment. So all depend upon the application whether it is a stateful or stateless application. So thank you all. In the next video, we will discuss about the node maintenance and node selector.